Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12th maths continuity and differentiability part 2. We have a humble request for you. Please subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's class. So, example 5, example 6. In the last class we have completed example 5. Let us see example 6. If fx is equal to x plus 2 where x is less than 0, 2 minus x where x is greater than 0, k where x is equal to 0. Determine k so that f is continuous on R. So, mm, for this we have drawn a graph here, and looking at the graph, and since f(x) is equal to 2 minus x for x is greater than 0 and fx is equal to 2x plus 2 for x less than 0, the linear polynomials f is continuous for all x element of R. So element of R means real number, element of real number. So we can write here that limit x tends to 0 minus fx is equal to limit x tends to 0 minus x plus 2 is equal to 0 is equal to 2. We can also write limit x tends to 0 plus fx is equal to limit x tends to 0 plus 2 minus x is equal to 2. Therefore, limit x tends to 0 fx is equal to 2. So, in order to in order that f is continuous at x is equal to 0, also limit, so we can write f is continuous at x is equal to 0. We can write limit x tends to 0 fx is equal to 2 is equal to f0. Therefore, f0 is equal to k is equal to 2. if k is equal to 2, f is continuous. Continuous for all x element of real number. Next example, example number 7. Prove that polynomial function is continuous. So say fx is equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a0, where ai is element of R, where I is equal to 0, 1, 2 till n. an is not equal to 0, is a polynomial. Is not a polynomial. Now we know limit x tends to a, x to the power n is equal to a to the power n. Limit x tends to a, ai is equal to ai. Limit, why? Because limit of a constant function. Next, also we can write limit x tends to a, bracket f1 x plus f2 x plus dot 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 plus fn x is equal to limit x tends to a, f1 x plus limit x tends to a, f2 x plus dot 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 plus limit x tends to a, f n x. Now limit x tends to a, fx is equal to limit x tends to an x to the power n plus a n minus 1 x to the power n minus 1 plus dot plus a0, which is equal to limit x tends to a an limit x tends to a xn plus limit x tends to a n minus 1 limit x tends to a x to the power n minus 1 plus limit x tends to a0, which is equal to an a to the power n plus an minus 1 a to the power n minus 1 plus dot. In this way it will continue a0, which is equal to f function a. Therefore we can write a polynomial function is continuous for all x element of R. So example 8, prove that fx is equal to x is continuous for all real numbers. So we can write fx is equal to minus 1 where x is greater than equal to minus 1 and smaller than 0. Then 0 where x is greater than equal to 0 and less than 1, and 1 where x is greater than equal to 1 and less than 2. In this way it can continue. Before that also, in this way it can continue. Now therefore f is a constant function in any interval n plus 1 where n is element of z. Similarly, x is a continuous. X is continuous. X is continuous in all intervals. In all intervals n and n plus 1, where for x element of r minus z. Now we can write fx is equal to, now fx is equal to n minus 1 for n minus 1 is less than or equal to x is less than n, or n where n is less than equal to x and x is less than n plus 1. Let x equal to n and n is the element of z. We can choose delta is greater than 0 such that n minus 1 is smaller than n minus delta but less than n. Therefore, limit x tends to n minus fx is equal to limit x tends to n minus 1 is equal to n minus 1. Choose delta greater than 0 so that n minus n plus delta less than n plus delta n plus 1. Therefore, limit x tends to n plus fx is equal to limit x tends to n plus n equal to n. Therefore, limit x tends to n fx does not exist. So we can write therefore f is discontinuous for all integers therefore f x is equal to x is continuous on r minus z and discontinuous for all n element of z. So our next example is find k if the following function is continuous at x is equal to 2, fx is equal to kx plus 3 where x is less than equal to 2 and fx is equal to 7 when x is greater than 2. So we can write here limit x tends to 2 minus fx is equal to limit x tends to 2 minus kx plus 3 is equal to 2k plus 3. limit x tends to 2 plus fx, limit x tends to 2 plus 7 is equal to 7. Therefore, limit x tends to 2 fx exists if 2k plus 3 is equal to 7. That is, k is equal to 2. For k is equal to 2, f2 is equal to 2 multiplied by 2 plus 3, that is 7. Therefore, limit x tends to 2 fx is equal to 7 is equal to f2. Therefore, f is continuous at x is equal to 2 if k is equal to 2. And this is the end of today's session. Before we close today's class, we request you to subscribe, like and share our YouTube channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you for watching our videos and supporting us. Keep supporting. Thank you very much.